In question 9, there are quite a few marks available here just for being able to use your calculator effectively. So we've got this relationship between the number of coyotes and foxes. And in part A, we're asked to find the value of A and B such that C equals 80 plus B. So, in terms of finding A and B, all you need to do is enter this data in your TI Inspire as a list, and then once you've completed it, go to Analyze Data to Variable Statistics, and look at y equals mx plus b, and you should be able to read off the values straight away. So you end up with a equals 13.4 and b equals 137.5. So once you've got that in this form here, you can use that to generate an estimate for the number of coyotes at any point. And part B then asks us to use this equation. So we've got, here we've got C equals 13.4t plus 137.5. So in part B then we can just substitute in for t equals 7, because it's after 7 years. And if we do that, we end up with a value of 231.3. And given that C constitutes the number of coyotes, we can say that that equals 231, as we're not going to be able to have 0.3 of a coyote. Parts C, D, and E, again, then really just getting you to use your calculator effectively. And indeed, in part C, there isn't really much need even to do that. So find the number of foxes in the reserve on the 1st of January 1995. Now, it says here, after T is starting on the 1st of January 1995. So if we wanted to find this, then we can elicit from this that that is the point at which T equals 0. So this is the function for the number of foxes after T years. So we can see that in part C, when we're asked to find the number of foxes in the reserve on the 1st of January 1995, we are effectively trying to find f of 0, which is going to be 2,000 over 1 plus 99 e to the power negative k times 0. Now, it doesn't matter what k is at the moment, because multiply anything by 0, this will equal 0, so e to the power 0 will equal 1, and we're just left with 2,000 over 100, which we can simplify to 20. So that's going to be the number of foxes after at the initial period, so 1st January 1995. Part D then is when we're asked to find, or it tells us in fact, that after 5 years there were 64 foxes in the reserve, and it asks us to find K. So the simplest thing to do then here is, if we take this function here and we graph it for, so we graph, well, let's say f1 of x on our TI Inspire is equal to 2,000 over 1 plus 99 e to the power negative 5x, and then we're going to graph f2 of x is equal to 64, and then all we're going to do is find the intersection once we've plotted those graphically, and if you do that, you will find that they intersect at a value of k is equal to 0.237. So this should be 5k. So we can see that if we plotted these, we're just going to solve these two graphically, and it enables us to solve for k, which is going to be k equals 0.237. In part E, we're asked to find the year in which the number of coyotes are the same as the number of foxes. So we've got our two functions here for coyotes and foxes, and again we're just going to plot these two graphs, and we are going to try and solve them graphically. So the equation for the coyotes is going to be in terms of numbers, so that would be y equals 13.4x on a TI Inspire plus 137.5, so that gives the population of coyotes. And then similarly here for the population of foxes, we're going to plot y, or f2 of x, equals 2,000 over 1 plus 99 e to the power negative k. We already worked out in the previous question, we said was, well, k was 0.237, so e to the power negative 0.237, and that is going to be multiplied by all to the power of x. And if we equate those graphically, we will find that the intersection is at 12.1 years. Because the question asks us during which year, if we started in 1995, it is therefore going to be at some point during 2007.